7 million years back, a gigantic asteroid slammed into the Gulf of Mexico, racing at an astonishing 60,000 kilometers per hour. The impact unleashed a force equal to over 100 trillion tons of TNT, carving out a crater stretching 200 kilometers wide. This cataclysm triggered a global disaster, wiping out a staggering 80% of life on Earth. While such occurrences are uncommon, history tells us that we've encountered even larger asteroids before, yet our safety remains uncertain. In his final book, the renowned Stephen Hawking warned that an asteroid strike would leave us defenseless. It's not a matter of if, but when. This isn't a tale from science fiction, it's a certainty dictated by the laws of physics and probability. To know more, stay with us till the end of the video. In 2012, astronomers discovered an asteroid that had a slim chance of colliding with Earth within the next 40 years. Then, in 2013, it buzzed by Earth, coming closer than some satellites. Just hours before that, another asteroid surprised us by bursting over Chelyabinsk, Russia. It was a colossal explosion, 30 times stronger than the Hiroshima bomb. Nobody saw it coming. Despite our efforts to predict these events, sometimes we miss the mark. The truth is, more asteroids will come our way, big and small. Some might visit in your lifetime, others far in the future. We certainly don't want a repeat of the dinosaurs' fate. But how big does an asteroid need to be to cause such devastation? Let's begin with something small, like a car. These space rocks hit our planet about once a year. If one struck now, it'd create a bright flash, but not much else. The atmosphere would burn it up. Larger asteroids, say, car-sized, visit every decade or so. You might even spot one blazing across the sky. Some pieces might reach the ground, causing a loud boom akin to city traffic. Mostly, though, our atmosphere can handle these encounters well. If an asteroid measures 1,000 meters across and is headed our way, it's a cause for alarm. Such giants strike Earth roughly every 6 million years. When it plunges into our atmosphere, it packs the punch of 750,000 megatons of TNT. About 50 kilometers up, it shatters into smaller rocks. These fragments rain down, instantly vaporizing tons of material, carving out a crater 16 kilometers wide and 700 meters deep. Locals would witness a fireball dwarfing the sun and feel the ground rumble like an 8-magnitude earthquake. Massive chunks, as tall as skyscrapers, hurl into the surroundings. 30 seconds later, an air blast races outward at over 3,000 kilometers per second. All this from just a 1-kilometer asteroid. Remember, the dinosaur killer was more than 10 times larger. We must take precautions. In the vast expanse of space, where celestial bodies drift silently through the darkness, there exists a looming threat that has captured the imagination and concern of humanity. Asteroids, larger than 1 kilometer in diameter. These cosmic behemoths, known as the planet destroyers, possess the potential to wreak havoc on an unimaginable scale if they were to collide with Earth. While the odds of such an event occurring may seem remote, approximately 1 in 50,000 every century, the consequences would be catastrophic, leaving devastation in their wake. Picture the aftermath of a massive asteroid collision. A vast crater, devastating tsunamis, earthquakes, and volcanic eruptions. Humanity faces a global crisis akin to the dinosaurs' extinction. Since 2004, the looming threat of Apophis, a colossal asteroid, has gripped us. Comparable to a sports stadium in size, its potential impact in 2029 sparked widespread fear and speculation about our survival. Fortunately, advancements in technology have provided us with greater insights into the movements of celestial bodies like Apophis. Through meticulous observation and analysis, scientists have determined that Apophis will safely pass by Earth in 2029, alleviating immediate concerns about its impact. However, the reprieve afforded by this revelation is tempered by the realization that numerous other hazardous asteroids continue to populate our cosmic neighborhood, their trajectories potentially intersecting with ours in the future. In the face of this ongoing threat, scientists have tirelessly sought innovative solutions to mitigate the risk posed by potentially hazardous asteroids. Three main strategies have emerged as potential avenues for intervention in the event of a collision course. The first approach, aptly dubbed the push method, involves deploying spacecraft equipped with propulsion systems to impart a controlled force on the asteroid, altering its trajectory and steering it away from Earth's path. Imagine the Herculean task of nudging a colossal boulder out of harm's way, employing precise calculations and strategic maneuvers to avert disaster. This method represents a calculated attempt to harness human ingenuity and technological prowess in the service of planetary defense, offering a glimmer of hope amidst the looming specter of cosmic catastrophe. In addition to the push method, scientists have explored the possibility of utilizing gravitational forces to divert asteroids away from collision courses, a concept known as the pulling method. One proposed approach involves deploying a specialized spacecraft known as a gravity tractor, which would hover above the asteroid and leverage its gravitational pull to exert a gentle tug, gradually altering the asteroid's trajectory and guiding it safely away from Earth. The gravity tractor represents a remarkable fusion of theoretical physics and practical engineering, harnessing the fundamental forces of the universe to safeguard our planet from potential devastation. However, the efficacy of this method hinges on precise calculations and meticulous planning, underscoring the complex interplay between scientific theory and real-world application in the realm of asteroid deflection. Finally, there exists the most controversial and high-risk approach: the utilization of nuclear weapons to disrupt and disperse potentially hazardous asteroids. This last resort option entails detonating a nuclear bomb in close proximity to the asteroid's surface, with the goal of fracturing it into smaller, more manageable fragments that pose reduced risk to Earth. While the prospect of employing nuclear weapons in space may evoke understandable trepidation and ethical concerns, proponents argue that it represents a viable means of averting a catastrophic collision with Earth. However, this method is not without its drawbacks and potential consequences, including the creation of additional debris and the risk of inadvertently exacerbating the threat posed by smaller asteroids. In the face of a looming asteroid collision, these are the strategies we might rely on to safeguard our planet. We're not just waiting for something to happen. We're actively testing these methods. Take NASA's DART mission, for example. They sent a spacecraft to slam into an asteroid to see if it would work. And guess what? It did. The spacecraft hit the asteroid on September 26, 2022, and changed its orbit by 33 minutes. That might not sound like much, but it's enough to steer an asteroid away from Earth, if we act fast. Right now, none of the asteroids we're keeping an eye on are going to hit us in the next 100 years, so you can relax. But that doesn't mean there isn't a lurking threat out there. We're resilient. About 800,000 years ago, a massive asteroid hit Earth, covering 10% of its surface with debris. And guess what? We survived. So, why wouldn't we be able to handle it again? If you liked the video, then do like and share. Subscribe to our channel for more such interesting content in our universe.